Do we start now, Sana?
Yes.
Do we start now, Sana?
Yes.
Ladies and gentlemen, we are live. So it's our fourth quantum technology meeting. I hope you have half as much energy as I have for this afternoon. We are going to discuss quantum for e-mobility. As quantum computing comes closer to reality, the big e-mobility players are exploring its real-world potential. That's why on Friday, the 26th of March at 3 p.m., we are asking leaders like Leonardo, e.on, Huawei, and Infineon how they link quantum computing to future safe and sustainable transport within the next 10 years. But few are talking about near zero latency data challenges just around the corner. It's estimated that each self-driving car will generate around 40 terabytes of data for each 8 hours of driving. But where will all that data be processed? And how will cars securely connect to next generation 5G networks and each other? Let's ask Teledyne E2B about their vision for quantum key distribution in e-mobility networks, because no connection is simply not an option. Most transport and e-mobility systems today are totally dependent on the Global Navigation Satellite System, so-called GNSS. But imagine the devastating impact if that were ever compromised. Let's hear the quantum alternatives that Spanish system integrator Technobit can suggest to the European GNSS agency if, for whatever reason, GNSS is not available. And most important, how can nearly 700 EPIC members contribute to the discussion by providing relevant quantum technology? So with plenty to discuss, let's unleash the power of quantum to guide us along the road ahead with a single photon. Join the top experts on Friday, March 26 at 3 p.m. Sign up early to participate in the Zoom room or watch live or later on the EPIC YouTube channel. Live long and prosper by driving safely. I can't hide that I'm as much as a Star Trek fan and a Photonics fan. Thank you very much, everyone, for being this afternoon with me. It is Friday. So in 2 hours we have weekend, and the last 2 hours of this week, we're going to talk about quantum technologies. First of all, I would like to thank Sana. Sana and me decided to take this adventure of bringing quantum technologies to the EPIC community because we both have a PhD in quantum physics and because we love this. And this is our fourth event, and we're getting such a fantastic feedback from many people, or bringing end users and telling them how quantum can help and asking them how quantum may help. We think it is the way to behave. I'm here talking on behalf of a fantastic team of people at EPIC. Organize events, provide access to the network, help you raise capital, have a website to find a job in Photonics, and we have a long list of market reports. If you're an EPIC member, you have access to all of that. Today, fourth quantum technology meeting. Write in your agenda the 9th of April if you are interested in QKD. We are bringing the entire supply chain all the way to telecom operators to understand how you can do test your technology in test beds funded by the Open QKD program. It's going to be quite interesting, 9th of April. And also, if you are simply a Photonics company and you love Photonics like I do, online technology meetings are announced all the way to the 5th of July. And then afterwards, we go on holidays to enjoy the sun, hopefully COVID. But write down the meeting on Monday. New medical devices. We're making a very important statement. Medical devices having very difficult problems to reach the integrators. We are trying to solve it, but I want people to understand it's a huge problem today. But really today is quantum technologies for e-mobility. Thank you so much to our sponsor, aextris, all the way in Switzerland, the micro-optics company that's combining technology with MEMS. They do fantastic instrumentation. If you're looking for a micro-optics and MEMS partner, you have to go to Switzerland and you have to talk to aextris. Thank you for sponsoring the event today, and thank you. The hero of this afternoon, I'm just an entertainer. The hero of this afternoon is Dr. Sana Pyka. Sana, what's going to happen in the next 2 hours?
Thank you so much, Jose. Nobody can beat this energy. We don't know what you're eating, but we have to find it one day. This meeting is going to be very relevant for the community because quantum technologies is getting now becoming a key factor in the automotive, and particularly when it comes to e-mobility. So we have very nice speakers from the European GNSS Agency, from Infineon, Teledyne, Huawei, Leonardo, e.on, and Technobit. But I would like to show the whole supply chain of all the people who registered for this meeting. And you will see, we try to cover it, all fields of photonics that can be used. We have, of course, our end users from Airbus, from car maker, from Volvo, and we have, of course, the optics manufacturing, the system integrators, people develop LiDARs, people developing semiconductors, the data and data management clouds. This is also very relevant for this field. And of course, the manufacturing equipment. We have to mention that we have 4 governmental agencies joining this meeting. The UK Department for International Trade, side by side with ESA, the European GNSS Agency, and the European Defense Agency. I'm very excited. I really want to see all the talks. So let's start.
I'm not excited at all. You know, when the meeting finishes at 5 o'clock, you're going to get a link in the chat. We tried this over the last 3 weeks and we love it. You get a link in the chat, you click on it, and we all appear magically in a website called wonder.me. We are all like a kind of bubble, and we will use it to get to know each other and talk to each other. Even if you only have 5 minutes, it's totally worth it. This is the best thing you can do before the weekend. And I would like to remind everyone, this meeting is also looking live in YouTube. So I want like people in the Zoom room to look fantastic as you're already looking. YouTubers, if you want to get in touch with any of the participants today, all you have to do is send me an email, jose.poto@epic-aso.com, and I will be more than happy for making the introduction. And that's it for us. Now, the time to shine is to the people in the Zoom room. Let's do business. Make sure you use the chat to talk to each other during the presentations. It's okay. It's okay. We see you typing. We want you to do business. The first presenter today. The first presenter today is very important for this community. We are welcoming Justyna Redelkiewicz from the European GNSS Agency, the head of section for consumer solutions. Tell us how the quantum community and how my friends can solve some of the challenges that GNSS is having in the future. The floor and the attention of everyone, Justyna, we are worldwide, goes to you. We can't hear Justyna. This is the thing with making the shows live. We are used to this. Justyna, in the bottom left corner of the Zoom window, there is a mute button, and next to it, there is an arrow up. You click on it and you select different options. Now it's great. Yes, Justyna.
Okay. Now, in my case, it's more difficult. I'm connected with the phone for audio, with the Zoom for video, so I hope we can make it together.
Satellite communication is making it great. We hear you loud, we hear you clear. Do you have some slides to share for us?
Yes, I sent them to Sana. If you could please share them, because so I just would like to say that I'm very happy to be here with you to explore the opportunities. I'm afraid I cannot tell you how quantum technologies can help, but I'm hoping that you will tell me how quantum technologies can help, because I'm working in the last 10 years in GNSS, in navigation. I'm just starting with quantum. I'm personally a big fan of this technology, reading quantum books in the evening and trying to find my way. But I'm really hoping on you to give the missing piece for the GSA. So I put on my slides the USPA introduction. You will see that it's a little bit complex, the situation on our side, because today we are actually called European GNSS Agency, in short GSA, but we are now changing name. So I already put this new name for you, so you can find us also in the future. I will explain why and what is going on. So we are the European GNSS Agency. We are working under the delegation of the European Commission to manage the 2 satellite navigation program, Galileo and EGNOS. And we are located, our headquarters is in Prague, but we have several locations across whole Europe. Can you go to the next slide, please? As you see here, we will discuss today about the future of transport. And still, despite the fact that many sensors are used together, we strongly believe that GNSS is at the core of these future transport systems. And here I just would like to recall that there are more than 100 GNSS satellites today in the sky, and it has grown tremendously in the last years. And we can also see together with the growth of these satellites, we can see the huge growth, exponential growth of the GNSS equipment. Majority of this equipment are smartphones, so all of us has already a space receiver in our pocket, but a huge part of this is also receivers used in transport. We can then discuss in detail. I have only 6 minutes, so I will move to the next slide. Please. Okay, so what we do at GSA, we are supporting the use of GNSS across all the verticals. So here I listed only a few of them: consumer solutions, all the modes of transport, but also precision agriculture, timing and synchronization. And we are also aware that GNSS plays a major role in these technology trends like Internet of Things, augmented reality, and so on. And what we do, we really support the industry in optimizing this technology, in adopting this technology, and in creating synergies with other technologies, among which also quantum is very important one. Can you go to the next one, please? So we are now in the transition period, and why is that? Because there is a new space regulation in Europe that is giving much more responsibility to the GSA. So we will no longer be responsible only for navigation for GNSS, but we will also lead the European activities in Earth observation, so geospatial data, and satellite communications, including the secure satellite communication for governmental applications. And because we are not going to be the navigation agency anymore, we also changed the name to the European Agency for Space Program. And I think for this community here, it is really a good development because we see synergies with quantum technologies, not only in navigation, but also in Earth observation data processing and especially in satellite communication. So more on that in the discussion. Can you move to the next one, please? Okay, so in practice, how we work. So because we are an EU agency, our services to the community, to the industry are free. So we are basing our work on so-called 3 pillars. So we work across the whole value chain. So no matter if you are a chipset provider, a device manufacturer, you develop applications, you are the service provider, we are there to help you to work to create some synergies between quantum and GNSS. And we work alongside these 3 pillars. So first of all, we have a unit that is responsible for market and technology research. We are publishing reports every year on the state of the GNSS industry, what are the revenues, what are the forecasts. So any information on the market you can get from us. And then we work on this demand support. So we really create like adoption roadmap on how to support the use of GNSS technology for all the verticals. And we have specific, let's say, KPIs, targets on how to reach this. And the last pillar is also very interesting, could be interesting for you because it's called offer creation. So we really fund, co-fund development of products and solutions that use location. And tomorrow, because we are becoming USPA, it will not only be linked to navigation, but also Earth observation and satellite communication. So we are managing European funds in this area of space data use. Next one, please. And because we are speaking today about next generation transport, I would like to just present this one slide on our technology research and where we see that technologies such as GNSS could contribute to this next generation transport. And what we see here on the slide, you can see a diagram, a kind of pyramid. And at the bottom of the pyramid, we summarized the 4 dimensions of change that we see that is leading to this automation and ambient intelligence to the future transport systems. And these 4 pillars are accuracy, ubiquity, security, and connectivity. And here we speak about location. So the automated systems require the location to be more and more accurate. So it is not sufficient to have a few meters. We are speaking about decimeter level accuracy available to everyone. We can discuss then how this can be achieved. There is also a big role of 5G in this accuracy achievement. Then we speak about ubiquity. So this positioning information has to be available everywhere, and no matter if it's indoor, outdoor, maybe for transport, outdoor is more important, But if we want to navigate from door to door, there is also this part of then seamlessly switching to pedestrian navigation, for example. The third pillar is connectivity. So it is more and more important not to know where, let's say, where our tracking devices are, but we need to know where, we need to be able to share our location. So all the connected cars of future transport, connected devices will need to share the location. So then at the level of the solution provider, at the level of the server, we are able to draw some conclusions and steer better our systems. And last but not least is the security. So the more connected we are, the more mobile we are, the more secure we need to be. Not to be able to secure our location from the privacy standpoint, but also not to be hacked, not to be spoofed, to ensure that our systems work correctly. So all these 4 pillars of change we are supporting in our R&D programs, and we would be very happy to see how to create here synergies between GNSS and quantum, especially in the area of security. It may be clear, but also in other areas. And so this will enable this fully automated transport systems of the future. And also here on the slide, I put a very important factor, because at the GSA, we look always from the market and business point of view. There is this trade-off also performance versus cost. So the users require more and more features, innovation, but they are not always able to really pay a big premium for that. So we also need to see how to achieve this big breakthrough without a big increase impact on prices. So I think that from my side, that's all. I try to be brief, but I will stay here until the end of the meeting. So I would be available with my colleague, Jean-Pierre Barbeau, that is also connected for the discussion part. Thank you very much.
Thank you so much for being with us this afternoon. That was great, Justyna, to set up the meeting like that, and to also understand that you are doing lots of things to help the industry, like Sana and me and the rest of EPIC. But we want to go now to the people and get some questions for you. The first one is coming from a big admirer of EPIC. Nuno is one of the people connecting and also investing on photonic technologies. Nuno Edgar for Photonics Precision Technologies. It's great to see you today with us. What's on your mind? I don't think we can hear Nuno, which is a pity because he's followed almost all the online technology meetings so far, but I will read his question. Is GSS involved in a startup incubation?
Can you hear me?
Yes, I can hear you loud and clear.
Okay, because I had some connectivity issues. Yes, indeed, we are very much involved in the startup incubation, and this is actually the activity that I'm leading personally. So now I will become as excited as Jose to speak to you about this. And indeed, we have just finalized our incubation program of 80 startups that we awarded on the 2nd of March. And we are going to launch still this year another competition where we will be accelerating, incubating startups from the idea phase to the prototype, to the product, and finally to the market launch. So if there are some startups here and you want to grow with us your idea, and the only condition is that you would use location information in any way or Earth observation data in any way, and you can come to us and we will help. And these activities will grow a lot in the coming years because we started now together with the European Commission a new initiative that is called Cassini, that is going to support startups across all the growth phases, from idea, from prototype, from product, growth financing. We are also collaborating with venture capital firms, with European investment banks. So this is a big thing for us, and I'm very happy for this question.
No, but this is not the end of the question. This is the beginning of the question. Now we're going to do a little bit of role playing. Imagine that I have a company, a startup, or a young company that is focused on timing solutions for navigation. Actually, yes. I do have a company like that here. Oscilloquartz. Anybody from Oscilloquartz in the room?
Yeah, hello, Jose. Yeah.
Yes, so we have a company here focused on timing solutions. Tell us what the company does, and let's do a little bit of role playing. How can GNSS help you?
Yeah, so basically GNSS is the base of our product. So we are relying on on Galileo here from Europe. So basically we are getting
no, but tell us what you do. Tell us what you do.
Yeah, so we are making synchronization, timing, and frequency. So basically to have the service running, so the 4G, the 5G, all the transportation and so on, you need to have synchronization on your network. And our product are providing such service either from GNSS or providing network from cesium clock.
So to a company like that, Justyna, how can you help? How can you incubate? How can you nurture this?
Okay, thank you for this. We of course know Redelkiewicz and other manufacturers of timing solutions. Indeed, we have also a specific funding program that is for the development of hardware. And in particular for timing receivers, we had a specific call of a few million euro where we were supporting to achieve the best timing accuracy for this type of solutions. And this call is already closed, but there are new coming. So really look at our website, because I think for companies like Redelkiewicz, it's not really the startup support that we are offering for really startups of 1, 2, 3 people, you know, like starting a new venture and not knowing really how to go to the market. This is already an established company. And for this type of companies, we have 2 funding programs. The one that I mentioned before is called Fundamental Element. And we have every month basically a call for research and development projects where you can use the unique features of Galileo to enhance your business. And we are helping, because for each project you have to also give a preliminary business plan. So it's not only about R&D as such, you know, reaching a certain TRL level. In every project you need to be really business oriented, and then we have to reach some milestones. And another funding program that we are managing is called Horizon 2020. This one is already over because it's 2020. We are starting now. The new phase of it that is called Horizon Europe. And in the area of navigation, we are going to launch a new call sometime around April, May. So it's soon that we are going to organize, you know, information days and explain the topics in detail, what will be the scope of this funding program. But I really encourage companies here to participate, because in these research programs, we really have quite a broad scope. So we allow and we encourage to have synergies with other technologies, with other sensors, with quantum, with LiDAR, with with the telecommunication development. So it's not that you have to really only work on navigation within these projects. What we are trying to encourage is, for example, when we had a project last year that was developing 4th level of automation for autonomous cars. This was a project with STMicroelectronics, Renault, and Ficosa. And within this project, you know, we always look at, do you have your end customer in the project? Because, for example, if you develop only a receiver, it is good that in the consortium you also have, you know, like your potential customers, so you are more sure to then bring this technology to the market. And it was a really successful project. Last year we managed to demonstrate close to Paris a self-driving car with the Galileo engine inside with these 3 partners. So this is really something that...
many of your partners, well, so many of the companies that they have applied for these proposals in our membership. I would like many of them more to contact you. You are the entry point for the GNSS. So any startup that is part of EPIC, all the startups with a few employees, this is the contact person to get some funding for the GNSS program. There's a question in the room for our head of photonics market research at EPIC, Tracy Vanik, all the way from San Francisco, California. What's on your mind?
Good morning, and good morning, Justyna. I appreciated your presentation. So as you are aware, we have many synchronization issues that are required for 5G, not just for terrestrial 5G, but also for satellite communications with 5G. And many of the carriers have begun to implement their own form of synchronization and clock independency from the GNSS. Are you going to be working with these carriers and with 5G to ensure the synchronization or to standardize some of these programs?
Yes, definitely. So 5G deployment is one of our priority areas right now. And we can support from two angles, let's say. On one hand, we are developing a specific timing service of Galileo, because with 5G, because of the higher bandwidth, the higher number of data that you need to send, you need to have much better synchronization and timing accuracy that could be even up to the level of less than 30 nanoseconds. So we are very proud of the fact that Galileo has super good clocks in the satellites, and that we are able to provide already today around this 30 nanoseconds easily, that is required by the European regulation, but we can go even lower, and we are working to provide also authenticated timing. So you are sure that the timing solution is coming from Galileo and it's not spoofed. And so we are working with the receiver manufacturers. We had example here, Oscilloquartz, but we also work with Spectracom, with Orolia, with Meinberg, with other manufacturers of timing solutions for telecom operators.
We're going to hear a lot of them talking later, and even we have the European Space Agency in the room, Bruno Leone. I want to discuss about this, but Justyna, I want to come to you after when we start talking about QKD. But now I really need to set up the mood with the room. You did a fantastic job with the opening presentation. Now we're going to go to one of the semiconductor manufacturers carrying the European flag worldwide. We go to Austria. We go to Austria to welcome our Infineon rockstar, Benjamin Bernabe. Thank you so much for being such a huge fan of EPIC. And thank you because today you're talking about your passion, which is quantum ion traps. The floor is yours.
Thank you very much, Jose. So I will share the screen. Just let me know if you're able to see.
Yes, I said well, it's Austria. I mean, it's not Regensburg.
Yeah, no, it's Austria.
Austria.
No, in the beautiful province of Cantonia with the nice mountains, sun is shining always.
As soon as I can travel, I'm coming to visit.
Yes, we're still looking for this.
We still cannot see your slides though. Let's see if there is some quantum cryptography that we cannot decrypt.
Yeah, I missed to press the share button. I was a little bit too excited.
Now we see them crystal clear. The floor is yours.
All right, thank you. Yeah, so as Jose already mentioned, my name is Benjamin Bernabe. I'm working for Infineon Technologies. My main work field is process development with connection to lasers. So I'm a real photonic guy, but also have the pleasure to be part of the extended quantum team within Infineon. And here I want to give you some brief overview of our views on this. But first, since it's a start in the quantum EPIC community, I want to introduce Infineon briefly. So with the acquisition of Cypress last year, we've been able to manage to reach the top 10 semiconductor companies in the world. We have roughly 50,000 employees, which 8,000 are doing R&D. And we would consider us as a leading player in automotive, power management and drives, sensors, secure system. We've talked about this already, wireless and also memories. So where do we see in Infineon the big markets for the semiconductor industry? And I think one is pretty clear. Everybody's talking about it. Friday for Future. It's the energy efficiency. So we need to be more precise and more careful how we deal with our energy, and of course the whole electromobility is going to increase the amount of energy that is needed, and this we consider as one big area. The other one fits to the topic. I will have a special slide on that, so I will go through this briefly. Is mobility. Security, everybody is talking with each other. We're going to release much more information in the World Wide Web, and we want to be sure that this is secure. And not just people trying to communicate with each other, also things are going to communicate with each other. So the Internet of Things and the big data that comes with it, I mean, these huge clouds that has to be dealt with, all these 4 segments we think are clearly in our semiconductor perspective. So what is the good thing working in the semiconductor industry, and especially for Infineon? So we kind of connecting the digital world with the real life applications. And you can see here the whole power segment, the automotive and the home entertainment. All this needs to be somehow connected to the digital world. And we from the semiconductor industry doing this on our daily business to make here life easier and more comfortable for all of us. So mobility itself, electromobility, I mean, it's a clear trend that the vehicles are going to get electro mobilized, and we have e-scooters, e-bikes, cars, autonomous driving cars, trains that will run automatically. And we think we have here a strong portfolio, so especially for the electromobility with our classical transistors coming from the silicon-based IGBT modules. Then we have here our silicon carbide portfolio, discrete power devices, MCU sensors. But you see also the other parts, they belong strongly to the electromobility. So the whole infrastructure to be able to use electromobility needs to be gained, and also we can be part of this. Automated driving, as just mentioned, takes a lot of sensors, radars, and of course, if you drive pretty fast on the highway, you want to be sure that you don't have to worry about nothing. Passengers, freight transport, clear. And more or less times are over where the only entertainment that you have on the car is the radio. So probably in the near future, it will be more like a home entertainment center, and it drives you from A to B without you doing anything. But where do we need quantum computing? What do we see? I mean, we was also thinking about this, of course, several years ago. And the demographic and social change. I mean, everybody of us know we're in the middle of a disease. And what we've learned with quantum, it will be possible to simulate molecules much faster or get a deeper understanding. I think one good example is the molecule caffeine. If you want to simulate the whole motion with the classical computer approach, you need 10 to the 132 bits, and then roughly with qubits, you could reach it with 100. I mean, 100 sounds little, but still not so easy to deal with it. And the climate change, which will also lead to different strategies for food production, and you're also gaining deeper knowledge about the chemistry and molecule interaction. As we just learned, urbanization, the whole traffic parking, and I think Jose made it nicely clear in his introduction, the amount of data that will be stored during autonomous driving will be huge, and somebody needs to be able to deal with it. And also for big data, we see here much room for the quantum technology. I mean, the big driver, I think, at the beginning was the Shor algorithm and talking about cryptography and to make life more secure. But I guess this will not be a low-hanging fruit, since also to make here some progress, the amount of qubits that you need to control is still pretty large. So I think this is a clear target, but not so easy to deal with. So overall, I guess there are a lot of fields where quantum can become a strong and important player. And where do we position ourselves as Infineon? So we're positioning ourselves with trapping ions. I mean, we have here a very close cooperation with the University of Innsbruck and Professor Dr. Blatt, that I want to greet here, that is doing here the pioneer work. And the idea is to trap the ions. I think that the concept is probably pretty clear, with some electromagnetic fields and then manipulate it with the laser. And we're able to do this pretty good so far. So we can control a whole bus that you can see here. I hope the animation will start to run. Yes. So we can control a couple of ions already, a quantum bus, and also entangle some of them. And what we're doing also at the moment already is creating these linear surface traps on a micro chip scale. So really we have them in production. And Of course, our vision is a little bit bigger, and here we're also part of the European project called e.on that I want to highlight here, where the idea is then to be able to control and create a huge array of qubits to be more to access more capabilities, and also the architecture. I mean, now we have a linear surface trap, but of course we want to be able to do here some more advanced architectures, and we're working here really on industrial fabrication level. Yeah, so who is the Infineon Q Continuum? So it's more or less this team that I'm showing here on the front. Back you can see the nice mountain, and here we have also one nice team member for Jose. It's Q himself that is joining from time to time. We're doing some publications, but of course, what we can do for you. I mean, nevertheless, we are a strong team, and you can really work on a manufacturing scale on quantum technology. So it's a little bit out of the university, more into real life manufacturing. And maybe for the YouTubers, if you're interested, we want to give 2 master theses: one metal stack technology development, very interesting, and the integrated optics feasibility study. So here in the middle, you can see our one of our chips. I mean, yeah, we're a bit proud of this. That's why I want to highlight it. And what you can do for us, of course, we need to be up to date in all latest developments in terms of optics and photonics in general that we can use for applications. But also, if you have good ideas, or you think you have there maybe some interesting sensoring idea or whatever, we're always happy to talk to people and get connected. So that was my talk. Thank you very much. I'm open for questions.
Thank you so much. That was really good, and you got the epic question. That's very important to make us go right away to answer in this question. Let me see first if we have in the room any direct comment on your slides. Otherwise, let me ask you a question. What is the biggest challenge you are finding in having these ion traps going to automotive directly, for example, or on airplanes?
To go direct into, yeah, I mean, especially automotive, it's a lot of qualification ongoing. So I think we're not there yet, but I mean, we're working on it. So, but to release something for automotive, it's not overnight. So it takes a lot of reliability issues and a lot of testing. And I think we're doing progress with also having less failures in the whole quantum computing thing, but we're not there yet. I think I don't know if you would like to drive in the car yet.
Yeah, sure.
Yeah.
I just let me see first. I saw that we have Yoshiaki-san. We saw your rising hand, and if I don't give you the word, I think Jose will be angry because you are dear friend. We don't hear you. Okay, I'm sorry, we don't hear you. But
Yoshiaki-san is one of our fans of the epic meetings. He's joining all the way from Tokyo. So for him, it's something like 1 or 2 in the morning. Yeah. Yoshiaki, in the bottom left corner, there is a microphone. Next to it, there is an arrow up. You can select different options for the audio.
Okay, can you hear me?
Yes, loud and clear.
Now.
Okay. Sorry. I'd like to just hear could you elaborate what you said? Integrated optics or integrated photonics? What's that mean?
So yeah, asking, can you elaborate on the integrated optics or electronics?
So what's the exact mean by the integrated optics or integrated photonics?
Yes, arigato for your question in the first place. And yes, hi. And the thing is that integrated optics, I mean, what we want to say about this is more or less the whole surrounding that is needed to be able to manipulate the ions within the ion trap. I mean, we need to have precise laser light to manipulate them, and the whole surrounding, that's what we call the integrated optics. And also photonics is the laser source itself. So it's more the surrounding of being able to trap the ion nicely. But if you need more questions, I can of course, give you a nice contact with one of the key team members.
Okay, thank you.
Let's see what our friend Dominique from Heidelberg Instruments can answer on that. Dominique, can you ask him directly your question?
Yes. Hello, Benjamin, and thank you for your presentation.
Tell us first what Heidelberg does.
Yeah, we make a maskless lithography system, so we can structure photoresist to create 2D or 2.5D structures. So it is used to make, like, for example, waveguides and micro-optic elements like micro lenses or any kind of freeform micro-optic structures. And I would like to know if you would have some need in this type of technology.
Yes, so thanks for the input. Yeah, and there's a need, and we're open and happy to collaborate with you. So I guess, I mean, I cannot say now the details, but it would be nice to have a direct discussion with you and the team, and maybe they can tell you exactly what they're looking for, and maybe you can show us what you have in your portfolio.
Usually we sell the machines, but we make demonstration samples for potential customers. But we usually don't do service because we don't want to compete with our own customers. But if you are interested in seeing what our machines are capable of, I would be happy to talk with you and your team.
Merci beaucoup. Of course, we would like to do this. Yes.
So you can exchange already contact on the chat channel, or
Yes,
just contact Jose. He will do the introduction for you as you wish. So you also let me see what are the other requirements for an ion trap. I guess the laser or the interrogation system you have. Do you have any specific requirement for these lasers on our compact?
Yes, I mean, there are a lot of requirements, but I don't have it prepared here.
So
we can go through this, of course. But yes, it's not like just very easy setup. I mean, I don't know if you have seen how this ion traps works. There's a couple of nice YouTube videos, and you see tables full of optics, and yeah, it's.
Let's continue this. Jose, you wanted to say something?
Yes, of course, Benjamin. Of course, I want to talk. Benjamin, I love when I have a semiconductor company talking about ion traps. I love it. And I'm not going to ask you too much about lithography, but you need to talk to Dominique from Heidelberg Instruments. But I would like to ask you about inspection, because I know that that's something quite important. In these projects that you are working in, especially in the Piedmont, are you looking at any inspection mechanisms to do the inspection of the ion traps? Is there a specific needs there?
Of course, we need to detect where are the ions located and how they move. And I mean, but I'm not the expert in this field, I have to admit. Jose, I'm sorry for not sharing any details. But yeah, there's a lot of stuff ongoing. And even, I don't know if you've heard about Trumpf. They also, I mean, Trumpf for sure, but they also have now a startup that are focusing directly on these sensoring applications. And yeah, but you're right. There's a lot of interest in this.
Okay, no, I want to go now to my head of photonic market research, who has a question that you're gonna like very much, Benjamin. Tracy, what's on your mind? She's preparing lots of quantum, lots of technology reports and market reports. Tracy, what do you want to ask the leading semiconductor company, Infineon?
I mean, this is amazing to be able to speak with Infineon and their section on quantum. What I'd like to know is, certainly from an Infineon perspective, what do you perceive will be the first commercial application for quantum?
That's a good one. Yeah, that's a, yeah, it's not clear yet. It's too early to say, but I think, I mean, especially about simulating molecules, I think here we're pretty far, and because of the security thing has so much attention, I guess there will be a strong drive in that direction, because it's important for everybody to have here a secured solution. But I'm not sure if this will be realizable in the next few years. Yeah, we're working hard on that, but maybe I think it's the diagnostics that will be the first one. So
we actually have a market expert in the room. We have Tematis in the room. Susmita from Tematis, are you with us? I think we may have connectivity programs. But Susmita, I will come back to you because I want you to answer that in your opinion for the market stability, because Thematis have prepared market reports on that. What would be the low-hanging fruit in quantum computing, especially ion trap-based quantum computing? Back to Sana.
Thank you so much. Ion traps very relevant. I would like to hear Bruno comment on from ESA, but let's do it just after the next talk that is coming from Ole from Teledyne E2V. Like that, we can hear ESA views about the ion traps and about the quantum system that Teledyne is developing.
Yes. Hello. Good afternoon, everybody. Bruno, briefly, sector. If you want to say something, Bruno, go ahead. Otherwise, I'll share my screen.
No, go ahead. Go ahead.
Okay. Yes. I hope you can see my screen.
Yeah, perfect.
Excellent. Yeah. Thank you for inviting me. It's a very interesting, different type of interaction here. I quite enjoyed that a bit more, not just speakers talking to somebody, actually very interactive. Great. Thank you, Jose, for keeping this live and interactive. As I've already heard 2 Star Trek references, I want to say, so if my headphone, you can see it has a little light, so I do look a little bit like the Borg now as well, if people who get that. But I'll come actually for quantum activities, and I'll talk a bit about what E2V does in quantum and how we can link that all into transport and so on. Just a little bit about myself. My name is Ole Kock. I'm the product development manager for quantum systems at Teledyne E2V. And I've got sort of two minds on. One is actually quantum technologies. How can they be used for? Who will actually buy these things? What markets can we share? And then with my great team of scientists and engineers, really thinking on how do we actually build these systems? And I'll talk about what we're actually building. A very brief snippet on Teledyne or Teledyne E2V, as not quite sure if everybody's heard of us. So Teledyne is actually a large 10, 12,000 people group now, over 3 billion in revenue. And I best describe us as we do everything. If it's difficult to do and not usually mass market, we'll have a go at that. So we are everywhere from up into space on custom CCDs. We do medical and life sciences like cancer therapy. We do underwater submarines. We've got several MEMS fabs in the company. So if it's difficult to do, we will usually be involved in that. But as I only have 6 minutes, I'll immediately go to the quantum activities. And on my side here, we've got really 4 streams of things in quantum. So one is for gravity sensors, so seeing in the underground. One is for timing, where we're developing our own atomic clock. And then one is for space, where we're actually bringing these quantum technologies into space. And some activities we have on quantum key distribution. As I only have 6 minutes, I'd love to talk about all these things in a lot of great detail, but I only have 5 minutes left, or even less. I'll focus on 2 main things, on our gravity sensors, on our atomic clocks, to see how they could link into transport like activities. Just one last thing also on how do we actually work locally here. So the quantum team, we especially are very open and outgoing, and we think the key is for very strong collaboration. So we work very closely with universities, National Meteorology Institute, but with a ton of companies as well. So we've got active projects with over 20 to 30 companies, a small snippet of those shown there. And we're then the ones who are bringing that to products with our development partners. So for atomic clocks, I mean, they have a wide variety of use cases, and there's very different ones out there, from very small and compact up to very large room-sized versions. And you can use them for lots of things. One is, for example, for global navigation systems. There's very excellent clocks on board. One is for telecoms, for example. That's the main focus of our atomic clock development, is looking at the 5G and beyond market, where we're developing specific solutions for, but especially for GNSS, as we are also in the defense and security and reliability arena, is what happens if GPS or any GNSS system fails or is actually just jammed or spoofed. We had a quick look online for a GPS jammer. You can buy it for 83 pounds, and I heard that they're nowadays going for 40 pounds from a Chinese supplier. You can buy one of these things and just some white van driver will put in his car, doesn't want his boss to know where he is, and suddenly a few mile radius, you don't have any GPS anymore. So if you think about autonomous cars or autonomous shipping or flying, what does this actually mean if you can block GPS very easily? And then for one, if you want the timing of the GPS system, Galileo, as for European here, and your atomic clock connects a local flywheel and keep you going, but also your atomic clock can use it to actually detect against spoofing. So you have someone who's a bit better at what they're doing, they might just sort of put you off course. And there's a question, maybe how much do you actually need it for cars? So I've got a little picture of a car here. If GPS fails, will autonomous cars just drive into trees? Probably not, because you've got enough visual cues around you. But imagine if you're an airplane, you're in the clouds, then what? And if it's an autonomous airplane, what backup systems do you have? And that is leading me into the other thing I want to talk about is also for gravity sensing. So besides atomic clocks, we are also building gravity sensors. And one application you can think of is for gravity sensors, you basically detect density changes in the ground. So sinkholes, one huge problem actually, which keeps creeping up. And I think it's more and more and more now that the ground keeps coming up and you have sinkholes forming. You can see a beautiful example out of nowhere. You suddenly have the entire road collapsing, which is not good. So we are building quantum gravity sensors, which can actually look into the ground and tell you if you've got a density problem down there. For example, people actually from mine shafts, which are just lingering underneath, or imagine London, 600, 700, 800 years, or any big European city of development down there. People don't actually really know what's underneath them. You've got about 50, 40 years in the history, you know what's down there, but anything older than 100 years, you have no idea what this old shaft was. So that's one thing we're actually developing these gravity sensors for, and we're quite involved with civil engineers and thereon. But if you think about it, gravity sensors, so for transport, great, you can actually tell you if your road will collapse. But actually going forward, you can actually use it for navigation purposes. So if you think about autonomous shipping, airplanes, you have your inertial navigation systems, and they give you a certain performance level, but they're not absolute. So what happens if you don't have any visual cues, if you don't have GPS holding you over, then what? You could either say, maybe like autonomous cars, are you happy? I've got enough around me to know where I am, I can easily stop. But if you're underwater, if you're in the sky, you can probably not do that easily. So we had a project with ESA, funded by ESA, to look into how could you actually use quantum gravity gradiometers to help you do absolute navigation. And we've run quite a few simulations on that to actually say, map matching is the key word there. How can you map match to the Earth? Because if you look at the Earth, we know the visual maps and the magnetic field of Earth, but actually gravity is also very, very distinct around Earth. So what can you do there? And you sort of think of, if you have your real trajectory, your INS system might just drift over time and get away. But if you'd have a similar map of the gravity around, you would actually have reference points to just get your INS systems back on track. And with that, I hopefully stayed very well within my 6 minutes.
Not only within the 6 minutes, but also within the scope of the meeting, and also congratulations on how the CMOS sensors of Teledyne E2B are really being implemented in so many different R&D projects. But this is not your first rodeo, at least not for Teledyne. You know how this works. This is an epic meeting looking for cooperations. I have 600 companies behind me. What can they do for you? What can you do for them?
Actually, good point. Yes, I've written a few cues down. Thanks for reminding me of that. What can we do for them? For one is actually we're technology companies, so we develop lots of cool gizmos components, atomic clocks, CMOS sensors, SPATs, and so on. I think another one with a quantum team especially, we're very open, collaborative, and so we actually are quite involved in lots of cross consortia, so anywhere from end users to developers and so on. So if you actually want to engage with us, say, I've got this technology, how could we interact with that? We're very happy to also take it to the wider community and do a consortium project with you together. And then what can the community do for us, actually? I think some of the players on here are actually a bit more systems people and similar. And we are more component providers. So we usually component subsystems. So very happy for people who have more system knowledge and similar to basically get in touch with them to say, how can our systems be integrated with bigger systems?
Fantastic. You know what? I'm super jealous about your headset. I want to be I want to be the Borg as well. I need to get one of those. Thank you so much, and thank you for quoting Star Trek 3 times in 1 hour. That's been great. Q, the Borg, and of course. But now I would like to have some questions in the room, and the first one is from Quantum Valley Ideas Lab. Nick, thank you very much for being with us this afternoon. What's on your mind?
Thanks, Oli. Yeah, so there's a lot of activity in the market or questions about the timing of the adoption of some of these GPS denied or enhanced quantum PNT systems. Oli, do you have any sense of kind of when you think some of the practical adoption of that would happen from like the gravity-based sensing or some of the other things you talked about?
Ooh, that's a very good question. What is the market there? Basically, if you split it to sort of early adopters and the mass market, I think in cars, it'll be a long time until we have proper autonomous systems in there, because you've got GPS visuals. If you think about shipping, or especially submarines and airplanes, these are bigger systems they can deal with, because in a car you need to have something very small and cheap as well. But think about autonomous shipping. I think that's one of the first ones there where autonomous PNT systems will come into play, because you have GPS available. But what happens if it fails? If you're just on the coast between England and France, very busy waterway, what happens if you don't know within a few tens of meters know where you are? So I think those are the first ones where this will come into play. And then, of course, the defense industry, at least in the UK and in certain European countries, are the ones who are very interested in driving the technology. So I think that's where the gravity map matching activities will probably have the first application. And then once you've got the early adopters, the technology will become more mature and cheaper, and then the other players will come along.
And just to follow on to that, right? I guess they could have used that gravimetric in the Suez Canal this week. But in terms of there's also, I think, a debate, right, on, is it going to be accelerometer driven, right? Magnetic field driven? Is it going to be gravity driven? Do you have any sort of perspective on which wins in that conversation, or is it kind of a correlation of all the pieces, do you think?
I think there will absolutely not be just one winner. I think the big question will be what combination of technologies is best for your specific use case. So if you're absolutely cost driven and have less care about size and volume, or if that's very small, you might go for MEMS technology. If you can tolerate bigger sizes, you might use more complex quantum technologies for those ones.
Thank you.
Thank you very much. Today we have the pleasure of having with us people from EDA and ESA. Actually, I live in Northpike. ESA is just behind these roll-ups. Bruno Leone from European Space Agency. Good afternoon.
Hello.
We are hearing, in every meeting, we are hearing about the amazing job that ESA is doing for the incubator program. So first of all, congratulations on that. I'm preparing a video just for congratulating you on that. But I would like to ask you, when it comes to all the technologies that Teledyne, that Ole has been presenting, we would like to understand a little bit what is the purpose of, what is the roadmap for ESA. And one of them for us, very important, is the link to the Galileo activities. Is there a roadmap, or is there a need for new sensor solutions for the, let's say, navigation 2.0 quantum enabled?
Well, as Oli already mentioned, navigation, well, first of all, let me tell you, I'm from technology, and there are many different, can you hear me?
Loud and clear, Bruno.
Okay. No, so I just wanted to maybe clarify that at ESA, there's been an explosion of interest in quantum, and a lot of different areas of ESA are interested in quantum. So there's the the sort of gravity sensing interest from Earth observation. You mentioned navigation, and Ole already covered a contract with ESA with that directorate, where they're looking at navigation resilience on the ground using gravity mapping and that sort of thing. Then there's also another big area, which is the quantum key distribution from space. That's another directorate, the Telecoms Directorate. And also increasingly important is the quantum computing for future big data mining and also optimization problems. So there's a lot of little areas that have developed independently across ESA. And I think currently we're in the process of trying to coordinate all this. But the roadmap, let's say that it's still in preparation. Let's say that there are different roadmaps for different areas. So there may be a roadmap for navigation, one for telecoms, one for Earth observation. So let's say that it's still a work in progress at the moment.
We organized a meeting on quantum for every market segment, and ESA is the only company who registered to all of them with different people. So on that, we are amazed. We are amazed at the huge interest that we are getting from ESA on this. We love that. I would like to go back to Justyna. Justyna, thank you very much for the great introduction. You also posted the website for the startup program, which I will share also. I already shared in YouTube as well. Justyna, there's quite a bit of emphasis on this. Quite a lot already. We've heard it already 3 times so far, one from me. And I would like to understand a little bit to what extent this can happen. GNSS failure. Is that something, are we too worried about something that will never happen? Are there real risks?
Okay, thank you for this question. Can you hear me?
Loud and clear.
Well, okay, well, I don't think that the risk is high. There is not. However, with all the GNSS systems, there are some, first of all, GNSS denied environments, meaning that GNSS is not available everywhere due to the frequency of the signal. So there will never be, for the future transport, a system relying 100% on GNSS. So I guess this is actually the key to compose the solution, that is having GNSS at the core for the absolute position, location, or time, that is an input that is then refined by other sensors and technologies. So I guess it is GNSS may fail like any other technical solution out there in the world, and but it is not, I would say, an issue, because GNSS is very complementary, and it is not, I mean, it is expected to work very well as it used to work in the last 30 years. You know how many disruptions of GNSS systems we had in the last 30 years, just a few, and it was not a big disaster, let's say. So I would say we are ready to operate. Galileo is already operational since 2016, and it's operational. It's working very well. We are committing to certain values of availability, but it is never 100% availability. So this is what I can comment, let's say.
You commented a lot more than I was expecting. I was expecting you to say, no, sorry, I can't comment. So that's a lot more. Ole,
no, but
I think
it's
yes.
just, it's just the technology as any other. You have to be ready to have your solution ready for unexpected. But GNSS is working perfectly well, and Galileo is, my big love. So there is no
Ole Kock wants to comment on your statement.
Yeah.
Ole, what's on your mind?
Just want to ask about, I mean, as you found, is you can buy GPS jamming very easily, £50 online. Are there any activities in Europe or similar to actually detect these jammers? We can know if it's happening, to know who it is, and find them very quickly. Is there any activities to have a GPS jamming detection network or similar?
Well, I'm sure there are. I'm not aware of the details of this, but I'm sure there are, especially in some critical environments like around airports, or in other places where it is really important to have GNSS being available all the time. But as a GSA, we don't, let's say, coordinate any large-scale activity on this. So I cannot give you any specific details, let's say. We had some R&D projects that were creating databases of such jamming environment and so on. I suggest you to take a look at our website. We have a full portfolio of projects you can filter by topic and learn a bit more on this subject.
Justyna, you're a star. I'm so happy that you're today in the meeting. Ole, thank you so much for a great presentation. We go now from one of the most beautiful areas of this continent called Europe, London. We go from London to Infineon, back to Benjamin, because Benjamin, there is a question for you from my dear friend, Ruth Huberts, CEO of ThinkMate Engineering. Ruth, I think you have a road mapping question. What's on your mind?
Yes, thank you, Jose. So the question I had is, while I heard about the implementation and that Infineon, of course, is not a research institute, I would like to hear something about the roadmap of Infineon. So what is the implementation plan of making use of all these type of devices?
Yeah, that's a very good question. And I'm sorry, I cannot share the roadmap plans at the moment in this meeting.
Yeah, but you might be able to say that it will be like in 5 years or in 10 years or in 7 years without
Something
sharing
like
a
this.
detail.
No,
So
yeah, no, I'm really sorry. Usually I like to be very open, but here I cannot not directly answer.
Benjamin, don't worry, and please never apologize at an epic meeting. Being here, it makes it great. You know, Ruth, we have to make a roadmap. We do have to make a roadmap. There is no, Benjamin doesn't want to say it. I'm going to say it on his behalf. We don't know. We don't know because there is no roadmap. And I would like to call the quantum flagship. Please, let's work together. Industry, not just the quantum companies, the real industry. We need to make a roadmap all together for this. And I would like now, because we already had the meeting started, we are all really full of energies. And the next 4 presentations are e.on, Huawei, Leonardo, and Oesia. First, we are going to go to one of the key companies. I go to my favorite city in the whole world is Munich. And I go to Munich to talk to Dr. Juan Bernabe Moreno. Juan, thank you very much for being with us this afternoon. e.on is a key company as an end user of the energy sector. I want to know, what are you doing at a quantum meeting? What is quantum computing to the eyes of e.on? And most important, how can we help you?
Yeah, thank you, Jose. Can you hear me well?
Loud and clear.
Yeah. So first of all, thank you for so much energy, bringing such an amazing topic. Also, thank you to Senna for just approaching me. I've been told, well, Juan, you have an slot with 6 minutes here in such a wonderful meeting. I was thinking of making the most of that. I decided not to bring any slides. I decided to kind of tell you the story of e.on, how we are driving that and how we think that you fit very well into what we are trying to do, right? First of all, e.on is, as you said, a very big energy company. We are in many countries and we focus on kind of distribution. We kind of operate our power grids. We focus very much on customer solutions, e-mobility being one of the most important pillars. And we focus on everything related to energy sourcing. Hydrogen is a big topic. And so we really want to kind of drive the energy transition, providing as much as we can our contribution. What my role is like I'm responsible for data and AI. And my job here is to make the most of our data assets to make this energy transition happen, right? Basically. So, and that's quite exciting. And I'm quite thrilled of kind of getting every day to work by doing that, right? Now, quantum. Why are we just caring about quantum? That's very simple because quantum for us is the key to solving many issues that we cannot solve with the means that we have today, right? Or the key to solve issues much better than what we can do with standard AI technologies or kind of very advanced AI technologies. And where we started is actually in the e-mobility space. Our first quantum use case is kind of a vehicle-to-grid optimization. We've done that with annealing technologies. But we've done that for real. So kind of we've implemented that, and that was kind of our first one. But as we saw, as we got familiar with the possibilities of this technology, it was last year, this year we have a huge ambition in terms of quantum. roadmap, as you said, Jose. And what we are kind of setting ourselves as objective is like, how can we just build up an ecosystem so that we cannot do it alone. You guys, you need kind of, or most of the people here, they need kind of problems that are pressing us a lot, right? In terms of energy transition. We have a huge backlog of problems which we would like to tackle with partners. When we talk about e-mobility, right, we have many problems already, many problems where we need optimizers, where we need to provide the right technology so that we can deal with these problems that are hugely complex that we cannot do today, right? Let me just say a few words. For us, as kind of energy provider, our energy company, the rise of e-mobility is a huge problem. Why? Because we need to dimension our ways. We need to be in a position of supply this energy in peaks that we didn't have before, right? And we are, for example, doing projects like e.on Booster, which is a cooperation with Volkswagen, where we have transient, big transient batteries that we place all over Germany so that we enable so fast charging. Of course, you can't really guess how many hours of optimization we have behind that, where to place that, how to size the batteries, how to kind of coordinate this kind of load with the local grids. So it's huge, the kind of the set of problems that we have to face here. Another one, for example, is like pricing. Of course, we make money. We are kind of commercializing energy as well. But what's the right strategy for pricing? How do we do it in a way that we make the most of the renewable peak that we have there, right? Renewable is very volatile. You don't know when you have how much wind, for example, right? If we could just connect a huge surplus of energy to a way of pricing that so e-cars owners see the possibility of charging in these particular time zones, in these dynamic tariffs, then we would have the car owners also helping that. So for us, e-mobility is simply a very good space because it's where kind of energy, the car manufacturers and the technology come together to solve something as critical as the mobility of the future. But that's not only the only set of problems we solve here. Things as important as, well, how do we kind of decarbonize our networks? How can we set up peer-to-peer energy communities? What's the right way of dimensioning communities? Those are kind of MP hard problems for which we see kind of a light at the end of the tunnel with this quantum technology, right? That's why I'm so excited, and that's why I wanted to come here to share that, to get ideas, and also to start a discussion with potential, energized companies willing to help us in this journey. That's how I would just end up my invitation.
Thank you, Juan. That was very nice speech, even without the slides. But I will let you go with no slides, but I will not let you go without the epic question. So you tell us a little bit the story about e.on, your center of interest, but we want to know what is it that you can do for the others from a business point of view? What is it that you can do for the others? And what can the others do for you now if we want to start some collaboration?
Yeah.
For example.
So what we can do for others, right? We are kind of owning problems. So we have the data, we have the infrastructure, we have also a very good set of professionals, and we are very close to the problems, and we are the ones kind of in a position of architecturing these problems so that we end up solving them. That's what we can offer. Apart from enthusiasm, apart from, we are the ones willing to drive the energy transition, and apart from a lot of young, engaged professionals willing to solve that, right? What others can do for us, we are building up an ecosystem. We are not a hardware provider. We are going through gates of technologies. We are also using many quantum technologies, but we are forming the ecosystem. We have a lot of research institutions also helping us. Here is the offer. So if you here to all the kind of attendees, right? If you think that you can help us solving this kind of energy transition problems, we are your company to talk to.
Juan, do you only do this software, I would say, part, or can we speak a little bit about the hardware part where quantum computers are used, for example, for optimizing battery with lithium sulfur? Are you?
No, we don't do material sciences. We follow very, very carefully the development of the battery technology, right? For example, one of the day-to-day jobs that we have is predicting the lifetime of battery, assessing kind of the state of charge. When a particular car is arriving at a point, then what we do is like we need, in order to sell or commercialize this energy, we need to predict the availability, the time this car is going to be kind of parked, and also the state of charge. So we really have to do a lot with batteries, but we are not designing or optimizing batteries from the material science perspective.
Thank you so much. Let me see if we have any comments in the room. Otherwise, I would like to engage some of the audience that are present with us. Philip White from... You are muted. Hi.
Hello, yes. I was just about to type something, actually. Maybe I should briefly introduce myself. I work for UK Government, Department for International Trade, helping UK companies export and encouraging and supporting overseas companies to come to the UK and collaborate. I was just going to ask Juan, is he aware of the project at the University of Sussex on using quantum technology for measuring lifetime or predicting discharge of batteries?
We are working with I think 12 universities. I need to check this one, but thank you for giving me kind of this. We are very active in UK, for example, with Nissan, the vehicle to grid corporations in UK. You probably have read that.
Yes.
Also, we are working with a startup called Q and Bo, so Q, which is kind of also probably having PhDs from Sussex. So it rings my bell, but I don't know exactly. But it's a very good pointer. Thank you.
Yeah. So it uses quantum technology, which is specifically relevant to this meeting, and it's relevant to your needs on batteries. I'll post a link shortly.
Thank you. Much appreciated.
Thank you.
Philip, it is great that you are Sana. Philip, it is great that you are here. I would like to congratulate you on what the UK and from the UK government, what they are doing in quantum technologies, especially on the test bed for 5G at Bristol. It is out of this world, the work done there. We are huge fans. I know John Rarity watches these shows very often. So John, you are watching. Congratulations on what you are achieving. I think you are an example. The test bed in Bristol is an example on how to reach the right community with quantum technologies. Sana, there is a question from Huawei.
I think it's the right moment for Marcus to comment right now, right?
Yeah, I wanted to basically ask e.on in the problem space you are working on. So, like, how much communication and shipping data around is actually needed? I will come back and you will see why I asked that question later in my talk.
A very good one. Obviously, we are very much depending on IoT devices, right? Communication is a limiting factor, but also if played well, is a huge advantage. With AI, we can embed some of the algorithms on edge. With quantum, we can't. Yet what we do a lot is like we really divide and conquer in terms of we tailor problems in a way that we solve with classic computing some of the kind of routines, and we kind of delegate some of the calculations to quantum computers in the background as required, right? Communications is for us, of course, critical, right? Very critical is the question, the answer.
Okay, I think we should have a chat later on that.
Happy to do that.
That's great. See Huawei with e.on. I'm sure that will be very interesting discussion. We have also Jean-Pierre from FTC. Jean-Pierre, how do you find the meeting so far? And do you have something to comment?
Well, can you hear me?
Yes, we do.
Okay. Well, I had a lot of trouble to connect to the meetings to start with. And okay, I put my FDC affiliation, but in fact, I'm working with Justyna full-time in Prague at the GSA. So I'm most interested in the GNSS parts of it and in the discussion regarding what happens if GNSS fails or whatever, or monitoring of spoofing or jamming events in Europe, etc. So up to now, it's been pretty interesting. And I would like to say, because there were also some discussions about the quantum sensing and what it can bring to us. What it cannot really bring to GNSS, but it can bring to navigation a lot. And I would encourage you to look at what Justyna has posted as link for a technology report where we discuss these aspects of GNSS being not used standalone, but used in conjunction with other technologies, just to bring this continuity that we need and this and all the qualities that we need, protection against spoofing, jamming, continuity, and use in safety critical applications such as autonomous driving in the future. And so I spent a part of my life writing these things, and so I encourage you to look and to go through the techno report. Okay, she showed the market report, the techno report as well. When discussing technologies, it's probably the best one.
Thank you so much. So stay with us. We'll still more discussions. We have also in the room from Airbus, Ricardo.
Yeah, hello.
Hi.
Can you hear me well?
Yes.
Yeah. So yes, I was just interested in joining in. I for different reasons I just could join in 5 minutes ago or so. So I haven't been able to follow the full discussion. But I'm interested in the topic in general from the perspective of communications. I'm mostly working in optical communications in Airbus for different platforms and different scenarios, and I'm interesting to see what quantum technology, quantum key distribution, quantum sensing, even because in certain topics Airbus is also interested in sensing. GNSS, as it was mentioned before, that's also could be a potential interesting topic for Airbus as well. So I just here scouting what is being said around and just to know what is around on the topic.
Ricardo, what you missed, you can watch on YouTube later, but what's important is what's coming up, because we will hear from Huawei, we still have to hear from Leonardo, and let's start right away with Marcus. Marcus, are you ready?
Yep.
Let's start then.
Coming. Share screen.
Excellent. So now you just need to go on presentation mode and you're ready.
Okay, perfect. Thank you very much for the invitation for that meeting here. I have to admit I'm very newbie to EPIC, and I'm also a bit a newbie to Huawei. So I'm basically start talking about how to embrace the age of light. And I was already hinting before that this is naturally more in the communication area. I don't want to bring the whole Huawei story, but just like Huawei research, to be clear, Huawei research is naturally also a big elephant already. That's not including development, by the way. So, but Huawei research is more focusing on the longer term topics, the more than 10, 20 years, probably down to 5 years. Then if it naturally comes to product innovation, this is sort of another topic. The areas of interest are in industrial solution for all types of industries. Naturally, we are coming with a strong footprint from telecommunication. Then in the technology area, naturally are all the cloud AI topics, wireless networks, optical systems, terminals and IoT things. So the business unit I belong to is actually more the optical systems area. And there's naturally fundamental research topics. If it comes to light, then there's a lot of research needed in the new components and new devices area. So coming to the age of light. Age of light is basically now. I mean, we know since many years already how we transport light through fibers. And we want to apply this type of age of light to many different industry and adapt it to the needs of different industry. basically going out of the telecommunication part only. I just have shown here a bit of like all types of use cases which need optical communication for a variety of application scenarios. This goes from the systems from food from farm to fork to the circular economy. Naturally, optical communication is much better in terms of energy usage than some of the copper-based communication and the wireless communication. And we already heard before, like zero downtime is another topic. The more we rely on the communication systems, the more we need to also rely that the systems are up and running. And photonics is sort of the flagship science for this type of innovations. Our vision at the moment, and this is sort of like what we look into at the moment, and I will show you later a bit on that. It's what we call a fixed 5G vision. So we basically have lending the name 5G from the mobile guys and talk about the fixed 5G, which is sort of an optical communication vision, which basically builds ubiquitous full fiber connectivity. And that means basically not only using optical communications in the backbones, long distance systems, but going out really, really fine grained. I mean, fiber to the home, some people probably have that already, but we talk, if we go higher speeds, we go talk about fiber to the room. In enterprises, you talk about fiber to the desks, fiber to the rooms as well. In the factories, we have optical communication, which can be applied in different scenarios than we can apply communication today. So basically going out with optical communication into the very fine granular area. That also means that naturally we are immediately talking about a complete different cost structure if you go fine grained. I mean, large optical cross connects is massive investments needed for the development and for running them. But if it goes fine grained, you have only small components which need to operate cost efficiently. That the use case and the business case you have in mind makes the case. Now that's the F5G. That's what's currently happening. There is in the ETSI standardization activity going on that evolution of the current networks and standardizing that. This is sort of this peak rate of the 10 gigabit, experienced rate 1 gigabit type of systems and networks. But we basically want to grow that towards beyond fixed 5G. And if we grow that beyond, we basically want to get sort of, or in certain areas, get rid of the fiber. So going full optical, not bound to anything. And we naturally want to look into the sensing part. So optical communication can be used in many different applications for sensing. And then naturally on the speeds, we start talking even higher speeds. That's not too much of a surprise in telecommunication. So I already heard before on the ecosystem. Also, we rely really on the ecosystem. And in Huawei, we basically look at it from the more fundamental technology research. We basically have collaborations with academies and research institutes all over Europe. We engage with a set of partners on that more fundamental technology research. The next step would be more the application of the technology research. That's where we feel the European framework programs are very handy. Things in the Photonics Europe, PPP, Photonics 21 as it was called, the Smart Network and Service Joint Undertaking, Networld, 5G IA type, all type of this type of activities we are very much involved in and or interested to be more involved in. Then I already mentioned the next step is the standardization part. I already heard standardization on the quantum computing side. we now have naturally more the view on the communication part of the game. And there are naturally a whole set of industry promotions, including EPIC, to promote technologies, promote views, get people together, make matchmaking in various ways. So the bottom line, we are looking for deep cooperation based on areas of interest for a win-win-win situation. Currently, the European project program is starting up. So we would be very interested in collaborating with partners in some of the photonics components area. And to be very clear, we do a little bit of research in that area, but I mean, with the business unit I'm coming from, we are looking at that as a user, as an end user of components and technologies in the photonics space. Basically, we are able to bring the requirements for novel communication systems and areas we can look into, but we don't intend to be engaged in deep down technological research on the component level. And then in case somebody has interest in that, he's naturally more than welcome to join the ETSI ISG industry specification group on F5G to basically streamline standards and specifications for the industry. There we try to really look at the optical communication system more holistic, and we look into going into several verticals and industries and how and what they need. That's why also I have shown interest to the talk from e.on, because this is a different industry. That's not telecommunication anymore. And we would be very interested to look into the problem space of these different industries and how communication can help there. And with that, I thank you very much for listening. And yes, together we can make it happen.
Together we will make it happen. Thank you so much, Marcus, for being with us. I would like to remind everyone that Huawei now is very interested in joining EU projects as end user and trying to be partner of that. Can you elaborate on that, Marcus?
Yes, it's. I mean, we are a system vendor. Huh? We are selling from large to small scale systems for communication in the wireless as well as in the optical space. Now I'm coming more from the optical space, and our interest is not to do everything ourselves. We need the whole ecosystem, and we are very interested to look into the European markets and source from the European markets components of whatever kind it fits into communication systems. And that can be from very hardcore high speed to very low cost, low speed type of components.
Okay, so now let's talk about the real business here, which is 5G and QKD. And for me, still I have a lot of doubts. And I don't know if you're going to answer any of my questions or some or all of them, but the first one is very clear. So 5G has been standardized heavily with Huawei at driving seat, and that has been fantastic to be on the passenger seat seeing this. I still do not know in the autonomous car of the future if the data is going to be processed in the car or on the cloud. And if so, where is QKD? Are we going to secure with QKD every single data that is transmitted from the car to the cloud? And you saw my previous presentation. I'm talking about 40 terabits per second. 40
yes.
terabits in 8 hours.
I like the 40 terabit because that's where the optical communication comes in. You need to have optical communication for the large amount of data to ship. But honestly speaking, I mean, it's in 5G, it's a combination first. Huh? So QKD can only be applied to part of it. I'm not sure how much QKD is working in the free space optics. Probably experts can help me on that. QKD is naturally a interesting technology for the optical communication because security is an important topic anywhere. So QKD is in that sense an interesting topic. At the moment, the security discussion, I think, has just started.
Indeed, we are talking about the quantum internet now, which will be this parallel internet to just exchange the quantum keys. So just exchange the quantum keys, we need a new thing. And for me, it is clear, it is very clear how we're going to do this. And ID Quantique is really leading this, how we're going to do this in the fiber to the home part, in the classical access network, also in the but when we talk about the front haul on 5G, I have absolutely no idea how the QKD is going to be implemented. Tracy Vanik is the head of photonic market research. He's been working heavily on the front haul for 5G to know what is the status. Do you have any idea how we're going to secure the front haul of 5G with quantum key distribution in the coming years? Is there any plan? Did you come up with something related to perhaps the timing that needs to be an issue that needs to be addressed for the front haul on 5G networks?
So on, excuse me, I'm sorry, is it for me or is it for?
Yeah, of course, Tracy Vanik, head of photonic market research at EPIC.
I just wanted to be sure. I'm sorry, Bernard. So Marcus. So yes, security is absolutely an important aspect of any type of communication, including internet communication, extending down into the front haul. However, what has currently happened is it is mostly end users that are responsible for securing their own personal systems, with some general security being provided from the network. It would be wonderful if there could be more security provided from the carriers to help make their users safer in their homes and in their businesses. But I have not run across any suggestion of particular encryption techniques or other types of hardware, or apart from, you know, basically looking at synchronization. Is there anything, Marcus, that you're familiar with?
Yeah, the front haul, I mean, you can always secure communication. Huh? It's at the end of the day, it's a cost issue. That's also, I guess, the reason. I mean, at the moment, for example, we are currently standardizing the 50G PON access technology. And there is just at that very moment is discussion on increasing security for the access part. But that's not QKD based yet.
We are talking about e-mobility. And with e-mobility, unfortunately, we cannot plug the car with a fiber. It's about free space communication. Philip from the UK government. I did my PhD at Bristol University. I think it was clear by now that I did that. I am very interested on knowing a little bit about the AirQKD project. Do you have some information on the top of your mind to share with us about the AirQKD trial?
Yes. This is a trial involving BT Labs, Toshiba, as you'd expect, because they've both worked for many years on QKD over fiber. And it's led by Andrew Lord of BT. I was actually in touch with him just today, and I plan to post on LinkedIn later, but I don't have much information. The grant is very brief. I can post a link to that. But there is a video they gave, a talk, last November at the Quantum Technology Showcase. I think I'll try and find a link for that video and post it.
Don't worry, Philip, because I think he showed the video when he was keynote speaker at our previous event here. And Andrew Lord is very engaged with EPIC. Andrew, you're watching. Thank you so much for all your support. But now I think that we have more or less put a nice atmosphere here. It is time for one presentation that perhaps we've been looking for the most. We have one of the flag holders of the European industry in the room. We have Massimiliano Dispenza, CTO of Leonardo, to talk to us about quantum technologies for e-mobility. Thank you so much, Massimiliano, for being with us this afternoon. It is sunny, it is almost the weekend, it is the best time to hear from Leonardo, to hear from Massimiliano. The floor and the attention of everyone goes to Italy, goes to you. Massimiliano, are we connected?
Okay. See you. First of all, can you hear me?
We have some connectivity problems,
which
we are going to solve, because there's no way I'm going to leave without hearing Leonardo. So I'm going to ask my team to be able to call you so we can have better quality sound. Can we try again, Massimiliano?
Yes, can you hear me?
I think we
Can you
can.
hear
Let's start
me?
like this, and if not, we will very rapidly switch to a phone connection. But let's start. If you go to slideshow mode,
can you see the presentation?
we see your
Yes.
screen. Please go to slideshow mode.
Okay. So okay. Maybe I can. It's better hide my. Okay. Okay. Anyway. Second to hold, it was very interesting to follow you so far. In fact, I'm working for quantum technology labs in Leonardo. Okay, I want to start my discussion from our business. It's a business with
Massimiliano, caro Massimiliano, we need to go slideshow mode, presentation mode, so we can see your slides the way that you deserve.
Yes, I see them in slideshow.
Then that means that you are sharing with us the wrong screen. That means that you have two screens in front of you and we are seeing the other one. So for doing that, stop sharing your screen and then start sharing your screen, and then you will be asked which screen to share, and then you select the one where you see the slide full screen.
Okay, this way again.
Because it's a pity that we don't see this full screen the way that it's deserved, because we are really excited to have Leonardo in the room.
Okay.
All right. I think we are having some problems now with the connectivity. So look, what we're gonna do is my team is gonna be able to connect you with the phone connection, I think. Okay. Let me see. Can we hear you now?
Can you see slides now? No?
Yeah, we see the slides
slides
well. Let's see if the sound works as well. Otherwise, we will have to do something about it.
Okay.
Yeah, it doesn't work. So we need to solve this with the phone. So my team is going to contact you. Massimiliano, my team is going to contact you so we can solve this properly. Because we need to see your screen, but don't worry, I have a fantastic professional team that we will solve this. In the meantime, I want to have a nice discussion with the rest of the team. Everyone here with us has shared some intelligence about how to collaborate, but I want to go back to Quantum Valley Ideas Lab. The reason why I want to go to you is because here we have collected a lot of end users. We have collected end users from very different sectors. And one thing that we always have a problem is that we want to have industrial events, industrial focus events for quantum technologies. My idea here is, do you foresee any potential idea, any potential collaboration, potential project in mind in which you could bring all these end users together to offer them something interesting in QKD?
So Jose, from a collaboration perspective, absolutely right. So my organization's focus is on TRL 3 to 6 to 7 kind of applied research. So before it kind of hits full commercialization, and sort of maybe after it might come out of academia in institutions. So the end user community, right? Those first of a kind of deployments become critical right now. That could cut across sensing, I think I'm looking for, or I'm interested in the practical things that can be deployed to solve problems, right? And you sort of heard it in some of my questions right around the magnetometers and the gravitometers and the PNT kind of conversation, right? So that's an area of key interest, right? We don't
know what,
have
I'm super worried about something that you just said, which is TRL3. And TRL3, Nick, means very little to me when it comes to quantum technologies, because look what Ole showed us before. Ole showed us this. And then when we're talking about applicability, he said, well, in order for this to reach the market, we had to go through a series of integrating processes to make this smaller. So how do we define the TRL? This is not the final system at all. This is not the system is commercialized. Ole, right. Would you consider this TRL3?
It probably depends on who's the user. That's basically what defines what TRL. probably TO3, probably level 4, we're just about at. And then probably 6 is 5, 6 are knocking on the door for the very first initial users. If you think about proper integration into a mass manufactured, we are very much in the lower TRLs.
For me, when it comes to quantum technologies, Nick, it's very hard to define TRL because the current technology development has 10 years time to market, and the final system doesn't look at all like the one that is going to be commercialized. At all. It's going to be different shape, different size.
Sure. Yeah, I agree with you, right? And I think that's a debate, right? Of like, you know, my organization, like the mission that we're on, right, is to actually get it to a, you know, a real usable TRL 6 or 7, right, for some of those use cases, and then, you know, figure out, you know, where that goes from commercialization perspective, right? I think there is a gap there, right? Like it takes, but the reality is that going from 3 to 6 to 7 is a long process, right? It's 3 to 5 years for most projects, right? I would think, and significant investment and potentially consortia of people, like the slide you just showed that Ole had with, you know, 6, 8, 10 logos on the bottom of the picture, right? So I think that's the reality of it. I think it also then you gotta apply good product management practices through that process, right? To kind of figure out where the market and the problem really is, and figure out if you're really going to have an MVP out of that at the end of it.
So the thing is that the end users that you have seen today, we have e.on, we had Volvo, so we had really lots of companies. Airbus is in the room with Ricardo as well. We had lots of companies who are really pushing for this. And for the biggest problem that I'm having while making a fully industrial quantum industry here is that we cannot define technology readiness levels whatsoever. And we tried. We had a meeting on quantum for space. We tried, really tried. It is impossible.
Yeah, I think you start with the problem, right? And the reality is, you know, the reality is these things are solving problems that are in the classical market, right? They're solving you're solving a GPS denied problem, or you're solving an improved navigation problem, right? Those are being done with classical technologies and approaches today, or maybe underserved by those classical technologies, right? The goal is not to, you know, quantum's a feature of making a better navigation device, right? You know, it makes it obviously more complicated and potentially more elaborate, but you're delivering improved navigation through the use of quantum technology, right? And I think that's the way I think of the problem, right? Because then you can solve a specific problem and take that problem to market, and go to market with a product that makes sense, right? So, you know, how the TRLs line up, good point. That's a bit of a subjective discussion, right? But the reality is, you should be able to have something that somebody can use in their, you know, real world environment at that 6, 7 level. That's, you know, a real proof of concept or prototype of what's going to really work.
I think when it comes to defining technology readiness levels for not fully mature processes, we always have to listen to the European Space Agency or to the space industry, which at the end of the day are the ones who define TRLs. We actually adapted it from the space. Bruno, are you still with us? Ciao, Bruno. We are having this discussion here, which is very important for industrialization of quantum technologies. It's for us very hard to define the TRL of some of the developments. Like, for example, I showed the gravitometer that was shared by Teledyne before. For us, it's very hard to define a TRL if we don't know how the system is going to look like. But if somebody has said that before, who has done that before, is the space industry, it's actually the European Space Agency. Is there any activity or any idea on how to define the TRLs for some quantum technologies that have a time to market of more than 10 years? Tracy, we need 5G. This is today the internet is not being our friend. We need 5G. I'm gonna ask now my team if the problem with Leonardo is already solved, so we can have the presentation.
Leonardo
Let's see if we can go again. So let's try for the one more time, Massimiliano from Leonardo, CTO of Leonardo, talking to us today about quantum technologies. I could barely sleep last night hoping for this presentation, so I need to hear it. Massimiliano, if we can hear you. This is all right. 1, 2, 3, 1, 2, 3. Now he's muted, but I think it's not just that he's muted. He is, my team is at the same time trying to connect him. We are having a bit of a problem with the communication today, which is something that we need to solve in the short term. But I think it is time. It is time for us to get to know each other. Why not? It's Friday and it is time for us to get to know each other. So what I would like to do now is to ask everyone. We have in the chat my colleague from the PR section, my colleague Suzette, is going to post a wonder.me link. She's going to post a wonder.me link, and we are going to be able to, all of us, click it there and try to do what we came here to do, which is to get to know each other better. So all I want you now, the meeting is nicely over. It was a great meeting. We did our best. It was a good meeting. We had some good cooperations. But all I want you to do now is to click on this in the chat. You have the Zoom link. Click on it and close the Zoom channel. Click on it and close the Zoom channel. You will all appear in a different environment. Even if you only have 5 minutes, it's totally worth it, because there is going to have the chance to meet all of you in person and really have a nice discussion, because this is what we want to here to do. So first of all,
just one thing before we finish, sorry, Jose, that Leonardo so Massimiliano from Leonardo, he's trying to join, but he will join the WonderMe at least because of the technical issue with the Zoom.
Okay, so he's going to be at the WonderMe. So all I want you to do is thank you so much for a nice meeting. Thank you for 2 fantastic hours. It was great to meet all of you. Now all I want you to do is to click the link, to click on the link and close the Zoom window, and then we'll see each other on the other side.